Hi, so this video is just going to be a general sort of discussion of Venn diagrams. Now, this particular topic is not covered in great detail in the text. You can find some examples of Venn diagrams, especially when we're talking about and or events. For example, there's a Venn diagram uh, at the start of chapter or section 2.2 on conditional probability, right? Where what we have here is one set of uh, proportion of people whose parents completed a college degree, a proportion of people who went to college, and of course, what we have is some proportion of people who both whose parents had gone to college and who themselves went to college, some teenagers who went to college but whose parents didn't go to college, some teenagers whose parents went to college but they didn't go to college, and of course, a good number of people whose parents didn't go to college and they didn't go to college either, right? And this is based off of a data set collected by the authors here, and you can read more about it here, and I do recommend it. Um, but I'm just going to talk about how rather than chase formulas down, um, if you can draw out a good Venn diagram, if you have two events, right, that you're talking about, so a bunch of examples are like voting for Scott Walker and the college, having a college degree, which was one of the problems, the drug tests, taking drugs, testing positive for drugs. Anytime you have a conflation of two events, it's always useful to draw out a Venn diagram. And once you have a completely filled out Venn diagram, uh, it rather than chase down formulas, you can really just kind of use common sense to solve the problems here. And it's really more informative than just like looking up a formula and adding and subtracting and dividing stuff. So let's go ahead and yeah, there we go. Let's go ahead and draw Venn diagram here. Actually, you know what? Let's make it a little bit bigger. So here's our oops. Here's our two circles, and let's say this is x over here, and let's say this is y over here. All right, and let's say we're given some information about x and y. So this is just a problem in the abstract. It's not going to be a problem with specific values in it, but let's say p of x is 0.4, oops, 0.4, p of y is 0.6, and let's say p of x given y is 0.5. All right, so let me just scooch this to the left slightly so it's easier to see. Okay, so let's say we're given this information. Um, do we now have enough information to try to fill out this Venn diagram? I'm going to go ahead and switch my color here because let's say this information given to us and everything that we write or do from now on is going to be some sort of computation. All right, or us working it out on our own, some sort of reasoning on our part. So let's say, oh, um, okay. So the very fact that p of x is 0.4, let me try to click out of that. All right, p of x is 0.4, and that means the x circle, this circle here, its total sort of contribution to our probability has to be 40%, right? And in the entries of this circle here, P of y, there's a 60% chance of being in y, so this circle has to total up to 60%. And so this, what we want to do then is find P of x and y, right? If we know what P of x and y is, then I can fill in this, I can fill in these two other pieces, and I can fill in the outside. So can we find P of x and y? Well, there is a formula that we can invoke, but rather than talk about, I'll use it here in a second, but I think we could work this out with common sense as well. Y is 60% of the circle. We can think of it as maybe 60% of the area of the circle. It's not exactly that, but it's a good way to sort of conceptualize it. It's like, all right, so if y is 60% of the circle, then that means that P of x given y, what this particular statement means then is that, all right, out of the things in y, out of the events that consist of, the y consists of, half of them are in x and half of them aren't, right? And so let's make this concrete. Let's say there are 10 people. 4 of them are members of group X, 6 of them are members of group Y, and what P of X given Y means is that half of the people in group Y are also in group X. And so if we then were to ask, all right, how many people are in both X and Y? It's half of the people in group Y, right? And so how many people are group Y? Well, 6 people, or 60% of the total number of people. So that means 0.3 in there, right? What formally, the way we think about this is P of X and Y is P of X given Y times P of Y, right? And this is, of course, one of our given formulas. It was discussed a bit in Bayes' theorem when I did that video. It's in the textbook essentially as this formula here. If I multiply both sides by P of B, you would get P of A and B is P of A given B times P of B. But maybe it's best thought of in the ways I just described it, not in terms of a given formula, but just like if we try to think about what it means to both be in X and Y. It means, all right, first of all, I'm in Y, and then out of the people in Y, how many are in X? And that product then gives us this middle region here. Once we have that, I can actually fill out the rest of this Venn diagram. How many people are in X? Well, X is 40%, right? Or 4 people. And that must mean that there's 30% or 3 people here. Then there must be 10% or 1 person right there. All right, and now P of X 0.4 is definitely 0.1 plus 0.3. Then if we want to fill out the rest of Y, the total of Y is 0.6, 0.3 of Y is in X, so another 0.3 has to be sitting outside of X, right? And then lastly, who's sitting outside of both circles? There must be some people neither in X nor in Y. Well, what's in X or Y? Oops. Point 0.1, 0.3, 0.3, the total area here, or the total proportion here, is 70% or 0.7. So there must be another 0.3 lurking on the outside. Right? And once you've gotten to this point, you could literally ask any uh, probability question about x and y, and you'll be able to answer it. So let's start with some examples of that. Let's switch colors here, and let's pick something. Let's say, what is p of x or y complement? Well, what's p of x or y complement? Let's go ahead and take a look at this. I can pretty much ignore all of this now and just look at my Venn diagram here and say, all right, what's in x? Well, these two pieces are in x. What's y complement? This is y. Y complement is the stuff outside of y. So that's this and that, right? So p of x or y complement is this piece here, right? That's an x. This piece here, that's also an x. Y complement is this piece here, right? That's not in y. And the outside, right? That's also not in y. And so the three highlighted regions are the three given here. And so the probability of being x or not in y is 0.3 plus 0.1 plus 0.3. Right? And that gives you a total of 0.7. All right? Does that make sense? Now notice, I could have used a formula here. I could have said, all right, it's p of x plus p of y complement minus p of x, x, or y complement, which is, well, p of x is 0.4, right? That's given to us right there. Plus p of y complement, what's y's complement's probability? Well, probability of y is 0.6, so y's complement has to have probability 0.4. And then, oh, I mean, maybe instead of all that, I'll write it above. So 0.4 plus 0.4 minus, and what's x or y complement? Well, this is x. These, or and y complement, sorry. This is a, and this is x. Y complement is the stuff outside of y. And so x and y complement is just this piece here, right? And we can see that it's the piece that's dotted twice. That's 0.1. And 0.4 plus 0.4 minus 0.1 is also 0.7. But that seems a little needless once compared to just counting up all of the regions which formed this area. I mean, what did we do? We took probability of x, which is the sum of these two things, probability of y complement, which is this sum plus that sum, and adding those things together adds this 0.1 region twice. So we subtract that 0.1 region off, and now we only get one copy of it, so it's 0.3 plus 0.1 plus 0.3, which is 0.7. And so there was never any point in doing that once you have the whole thing worked out, right? They're basically the same. So you're welcome to do whatever you want to work this out, but I'm just pointing out that at this stage everything is laid out for us. All right, let's do another example. So let's erase all of this. Let's erase these dots. We'll probably, what are you doing? All right, let's erase those dots. And now let's go ahead and write a new problem. Let's say P of, let's say, X complement and Y. So P of X complement Y, I just have to look at these four regions again and go, okay, which one's X complement and Y? Well, that's Y. Y is these two regions. This piece is in X. This piece is not in X. So that piece is both Y and not X, or X complement. So my probability is 0.3. All right. All right. One last example. Let's do a conditional probability. Let's look at the probability of X complement given, let's switch things around. Let's say Y complement given X complement. All right, so what does that look like then? Well, so what we're looking at is, okay, of all the things that aren't in X, which is these two pieces, right? These two pieces are in X, these two pieces aren't in X. How much of them are in Y? It's like, well, there's the same amount that's in Y as outside of Y. So it does seem like, just right off the bat, looking at this, that half the, let me put a dot over here too, and let me circle this dot. Right? That all the stuff that's not in X, which is the two red dots, the circle dot, or half of it, is also not in Y. So that would be 1/2, and you'd be done right here. That being said, it's not always so easy to tell, and it's not always, the numbers don't always work out precisely this nicely. So let's go ahead and kind of work through the formula here to see if this Venn diagram and this formula in concert with each other could help. So we recall how to compute the conditional probability. It's the probability of both events occurring outside of the probability of the given event. So in this case, it would be the probability of Y complement and X complement over, the probability of X complement. All right, so the probability of Y complement and X complement, again, Y complement and X complement means not in Y and not in X, so that's this region out here. Not in X means not in this circle, so it's these two regions whose total area is 0.6. And we can either get that by adding together the 2.3s, or we know that there's 0.4 in here, so there's 0.6 outside, right? And 0.3 over 0.6 is 1/2, right? All right. So um, there's a bunch of problems like this, and they all more or less boil down to the same thing, that what you really want to do before even tackling the specific questions that you're asked is filling out this Venn diagram here. Notice that with all three questions in the red that we wrote down here, none of them explicitly said go find P of X and Y, right? But once we had P of X and P of Y and P of X and Y, and we filled out this Venn diagram, even though no one asked us to, it made doing all of these problems much easier. So, and that's because at this point we have a complete picture, right, of all of X and Y's possible interactions. And so hopefully that's helpful as you go ahead and do the homework. Have a happy Memorial weekend, and good luck with your homework and exams.